This is going to be a general talk about platforms. So how many people would say you've worked with a platform or something you would call a platform right now? So a bunch of people in the room, actually. That's good. And then how many of these folks, like you can raise your hand if that platform is what the DTO is building out and providing for you right now, or if it's something else. Something else? OK, that's cool. So I want to talk at a high level first to kind of set the playing field about what platforms are, some basic functionality you need in order to have some operational maturity for your applications. Are we all engineers building apps? All right, raise your hand if you're an engineer building an app. All right, cool. OK, hands down. Who of you are operators who have to manage applications that other engineers have built and thrown over the wall and they're caught on fire and they call you at 3 a.m.? OK, only Mick. That's fortunate for everyone else. So how many of you are product managers or project managers? Coordinating projects, OK. And then imposters? OK, right, cool. So a little bit about me. I do a lot of the tweeting. How many of you have heard of Twitter? Twitter? OK, I like hand-based participation. If you do the Twitter, you can tweet things. You can tweet at me. If you disagree with the things I say in this talk, you can live tweet that. That's fine. I'll get notifications on my wrist, but it'll be OK. Email. Who's heard email? Email. OK. So this is my personal email address. I happen to work for a company, but you can also email me here. So if you disagree with me in a larger sense and you want to write a full-on screed, that's where to send that. I write some things on the internet, and you could read about that if you like. Mostly around technical leadership, culture, the DevOps, things like that. And then I have to reset the counter on that terrible email joke, because I did it here today. Sometimes I don't do it, but, well, you're special. So I work for Pivotal. Yeah, we have a question?
Just a quick question. Will this presentation be available to us online?
Yeah, it'll be recorded, and I think Mick and Lindsay and their team will sort that out. Yep. So I work for Pivotal. They let me go around the world and talk about what I think are good ideas. I'm not a salesperson, so I'm not here to pitch you on what Pivotal does. I think we do great things, and I'll just talk about what those things are, and then you can decide for yourself. But it's worth it for me to just mention that I work for them, and I think that's all right. So I want to talk about the minimum viable platform. So if you're building applications, managing applications, or you're in any way responsible for software that runs anywhere and anyone actually uses, if you don't have the set of environmental characteristics that I'm going to describe in production, then you have a problem, right? Your application is hard to manage, hard to change, hard to keep online, and it's made worse by not having what I would describe as the minimum set of characteristics you need to have operational maturity. So I want to run through those really quickly. This is regardless of what solution you're using. You're going to find, and I think these will ring true for anybody who's tried to manage an application for real, and hopefully you'll see that, yes, we need these things, or we're trying to build these things, whatever they are. So you need dynamic routing and load balancing. When you put an application online, when you deploy a new app, you need to be able to go to it. You need to be able to have customers use it right away. You shouldn't have to fill out change request forms and update inventory lists in load balancers in order to get your application to be viewable. You shouldn't have to ask for DNS and wait for 5 weeks until your DNS change order comes back in. It should just be available. And also with horizontal scalability, if you need to increase the amount of instances of your application because you have high demand, you should be able to do that with a click of a button or one command, and you shouldn't have to ask anybody for additional work. So the automation around this should be built into your production environment. The next thing that you need is dynamic routing and load balancing, or dynamic backing services broker. You need to be able to provision back-end services automatically. So if you're building an application, it probably needs a database, maybe a caching layer, maybe a message bus. And you should be able to get those services without, again, building out and redeploying new infrastructure and new environments. You should be able to do it in an auto-provisionable way. You should also be able to provision access to existing systems that you need to interact with. And that should be something that's handled for you by the platform itself. So again, this can be typical things like databases, caching layers, message queues, but it would also be things like access to existing APIs or existing applications, existing data stores. That should be something that can be managed from a credentials and network access aspect within the platform, within the infrastructure that your application runs in. As developers, we shouldn't have to worry about the usernames and the passwords and the host names and the IP addresses of the applications that we're building and running, right? You need infrastructure orchestration. So a lot of people are familiar with AWS or IaaS, infrastructure as a service. And it's one thing to have infrastructure that has an API that you can program its characteristics or change it through a programmable interface, through configuration management. But I actually take this a step further. I think the automation for providing compute, network, and storage resources has to be baked into the system as well. So it isn't about procurement for additional infrastructure whenever you want to deploy a new app. It's about having a pool of resources available to you that you can dynamically allocate and expand. And that kind of changes the game a lot when it comes to trying to get new things online or to expand or change an architecture for an existing system. Is this not working very well? It's working well? Great. It's just me. So, I think this goes to that next level, that your infrastructure should be dynamic, and the automation for making it available, expanding and contracting, should just be part of the system. Right now, this is one of the things that teams, especially any team that's been deemed like a DevOps team, they spend a great deal of time trying to automate this particular piece. And there are solutions like that. That's already been solved. So we don't have to spend a lot of time there anymore. Taking it to the next level, though, you need health management and recovery and monitoring. And this has to be at several levels. When AWS loses an instance of a virtual machine, which it does with relative frequency, this shouldn't be a situation where your application goes down. This shouldn't be a situation where, I think it definitely quit. Yeah, that's cool. Things got real. Here, we're gonna just put it down. Can you actually hear me? Yeah, all right, we're good. Okay. So, all right. Thanks, Mike. I did a mic drop. Get that? Okay. It was so cute. Okay. So this is a situation where the recovery from failure, especially within infrastructure, within the applications that you're deploying onto that infrastructure, that should be automatic. We can do health checks, and we can do consistent monitoring. We can do it at the level of the instances of applications that are running. We can also do it at the virtual machine level. We can do it if storage disappears, we can reattach it. And this is kind of this model that you don't have special snowflake virtual machines or servers that you manage and care for carefully, that everything is destroyable and recoverable, right? And if you have that level of automation, then you have automated health management. And then you don't have people getting paged at 3 a.m. because a server died and your application went down. You need an immutable artifact repository. So way back in the day, I say way back in the day, but it's probably still very common. We would build Debian packages or RPM packages, right? And we would put those into a repo and distribute those to a bunch of Linux servers. And that was a method of getting a snapshot point in time, a version of a piece of software that you want to deploy to your infrastructure. These days, we use containers for a similar model. So who's heard of Docker, right? So Docker is a common container format. It's a company that did a good job at making a reasonable interface to building containers if you want to build and manage them yourself. And then you put those containers into a repo or a registry. But you need to be able to build that immutable artifact. And when we say immutable, we don't mean that you don't change anything. We mean that it is a point in time that in itself is unchanging. So you have v1 of an app, and it is a complete version of that application that can be shipped around within your infrastructure and spun up and spun down. You build version 2. It's a whole new instance that can be spun up and spun down. But you need to be able to handle that in a central way so that you understand what applications are available and running, what versions they are, what exactly is in them, where it came from, all these things that you need for compliance and auditing and so on. And then finally, I think bare minimum, you need log aggregation. So if you have 50 instances of an application in a distributed cluster of computing resources that might span hundreds of virtual machines, you have no idea where your application instances actually live. And if one of them starts to misbehave and throw errors, or if a user is doing an interaction that's throwing exceptions, you shouldn't SSH into a bunch of different machines and go searching through logs somewhere on the file system. Those logs should be available to you. So your production infrastructure should build a fire hose for you for application operators and application developers to get logs that are fully aggregated across the cluster. So you don't go searching for them, they come to you. And then the people who run the platform itself need to be able to get logs for everything. And that includes things like every event that changes the state of the system, who did it, when they did it. You know, the only thing we don't really have in there is why they did it, but you can try to extrapolate. But you need that log aggregation. There are more things that you need, generally, and each case is different. If I happen to be talking to a bank versus a government institution versus a startup, like everybody has a little bit of a different need. But these are the table stakes. You must be this high to ride this ride. Like, if you're building applications these days, if you're trying to use modern techniques like microservices or service-oriented architecture, if you're trying to decompose monolithic applications into smaller pieces, if you don't have a production environment that has these capabilities and characteristics, you're making more problems for yourself. It's actually harder to manage a microservices architecture without a good production environment and without a good automation pipeline, which is a whole other topic. That's a much harder problem. And it gets a lot easier if you have these types of capabilities available to you. It so happens that here at the DTO, they're building a platform that has this and more just out of the box. And that's kind of beautiful. And we'll talk about and actually see how that works shortly. So I want to draw one distinction because containers are kind of popular right now. So I'm gonna use a metaphor to talk about containerization. So if anybody's doing any work or reading about things like execution agents, like orchestration layers like Kubernetes or Mesos with Marathon or Docker Swarm, I just want to draw a distinction when it comes to platforms. So if you have the electrical components of a vehicle, you don't have a car just because you have those components. There are a bunch of other components you need in order to have a car. They're all complicated in and of themselves, and they all have to work in concert as well, right? That's terribly important. Tesla wants you to believe that if you have electricity, then you have a car, but even they have to admit that you need other things. So similarly, for platforms, just having containers and being able to run them is not a platform. Just because you can orchestrate work across a set of computing resources doesn't mean that you have developer enablement with a full suite of functionality, the things we talked about and potentially more. You still need to be able to provision these resources for the workloads, and you still need to be able to orchestrate the workloads across a set of infrastructure. But more importantly, you need to be able to tie that into existing systems, back-end services, and have an interface that's reasonable and usable for developers and operators. So there's more that you need. So I throw this out here for anybody who's worked on containers to say you're on the right track, but let's think about this at a higher level because there are bigger problems to solve. So Cloud Foundry is based on two primary layers. I won't get too deep into this, but Bosch is kind of like the operator's interface to running the platform. So most of the folks in this room, I think, will probably not do a lot of interaction with Bosch. Bosch is lifecycle management for distributed systems. It does particularly well at handling rolling upgrade and version infrastructure and versioned system definitions for clustered applications. And they can be stateful or stateless. And the team that's worked on Bosch a long time ago came out of Google. Google has a project called Borg. And if you've read the Borg paper, it's worth a read if you're into this sort of thing. And developers are really good at naming things, so they just took the R and the G from Borg and incremented them, and now we have Bosch. And I didn't put the logo on here because it's not that great, but whatever. This is a lower level layer. And we put on top of that Cloud Foundry itself, which is the developer interface to the platform. And Cloud Foundry is particularly good at running stateless applications. And when we say stateless, we mean that your business logic does not carry inherent state within memory or within individual processes, but that it manages that state in external services that are managed outside of the Elastic runtime. I want to make that distinction because an application that doesn't connect to anything and manage state in some way is mostly just a toy, right? It has to do something. But Cloud Foundry is particularly good at that and then connecting that to the rest of the world. And so that's going to be our interface, and that's what we're going to focus on today. So this is kind of a very bad architecture diagram that's also kind of out of date, but it describes some of the components of Cloud Foundry. A lot of the things that we talked about when we talked about minimum viable product and operational maturity are in here. We have a dynamic router. We didn't talk about authentication and role-based access, but that's all in there too. We've got a health manager. The cloud controller is the RESTful API where you manipulate your applications, right? And then there's a command line utility that you can use that connects to that RESTful API. You can also program to it directly. And we'll see that again today. The application execution system, that's the runtime environment. We called that DEA and Warden, but we actually rewrote it. We completely replaced it, actually. It used to be written in Ruby. So Warden is a containerization format, and then the DEA was the execution agents for the pool of resources where you distribute work. We rewrote it in Go, so we renamed it DA Go and Garden. Why not?
Keep going.
Yeah. But what's neat about that, just to give you an idea of the way that the team for Cloud Foundry happens to feel about upgrading software over time, is that we completely replaced the execution agent where all the applications live. And then when you deploy the version of Cloud Foundry that supports Diego, it's a rolling upgrade with no downtime. And that's kind of an impressive thing to gut, a core part of your application and replace it and not have any downtime. But that's the thing that we happen to care about the most, really, is the fact that you have to manage this thing for a decade or more, and we want that to be reasonable. The blob store is where we store our immutable artifacts, among other things. So that's where we put containers, these immutable artifacts, before they get distributed. We have service brokers, which connect to back-end services. A message bus ties it all together, so this is more like a service-oriented architecture, not necessarily a pure microservices architecture. And then we've got metrics and log aggregation. But that's the end of the boring slideware, and now I want to kind of get in and show you what this looks like. So live demos always go well and never have any problems, including the fact that I'm doing this mostly locally, and we'll see if that works out. But I'm going to sit down here, and then you should be able to see over my shoulder. So the question that I have for the folks in the back of the room is, can you see this screen? Can you read what's on the screen? No. OK, great. That's how I want it. Come closer. Kidding. Better? 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 Dude, come to the front row. Can we see this? Is that all right? OK. All right. So I've spun up a local instance, a thing that we call micro-PCF. So this is a way to demonstrate the capabilities locally. I do that to minimize potential catastrophe with network access, because I go to places that don't always have good network access. And I've just actually spun up a new version. So I'm going to use this CF command that we talked about before. And it tells me here that I need to connect to the API, which I'm going to do. So I'm going to set the API endpoint using this CF command. The CF is written in Go, so it runs on Ruby, or sorry, it runs on Linux, Windows. I forgot Windows. Like, I don't use it, so I couldn't remember the name of that operating system. And Mac. So that's good. So I'm going to set the endpoint, and then I'm going to log in. And I'm going to say that I'm an admin, because I like control. So one of the things to note is that within Cloud Foundry, all of your applications and services are segregated and mapped to relatively fine-grained buckets. And those buckets can be defined however the people who are running the platform want to define them. So I mentioned that there's an API. So everything we do goes through this API interface. I am a user. You have to be authenticated. Our authentication system is what's known as, this is fancy terminology, a federated single sign-on system. So the federation, you probably know this, right? But the federation part means we can use other back-end login and authentication systems. And the fact that a single sign-on means that when I sign on to the system, I have access to, through authentication tokens, to all of the subcomponents. But also, interestingly, the single sign-on mechanism within Cloud Foundry is available for application developers to use as well. So anyone who would have a login credential for the platform itself could actually maybe interact with applications that are deployed on the platform for use by developers or by operators. That's kind of neat. So then we have these orgs and spaces. So you can have many organizations, and this is just an arbitrary bucket. And then within that bucket, you can have spaces. And you can slice and dice this however you want. Some people do it by having like a sandbox area and a dev, QA, staging, prod sometimes, maybe for spaces. And then the org will be a project or a team or an agency or whatever. It's kind of up to you. And we'll talk about what that means when you slice and dice these things. But basically, it provides a level of isolation and role-based control, right? But this isn't nearly as exciting as maybe building something. So I've got this app called CFENV, and it's written in Ruby. So how many people think you can read Ruby? It's a very simple Ruby app. All right, well, we'll do it anyway. So who's developing? Are people developing in mostly Java? Or, yeah, we got some Java. We got Ruby in here probably. Some folks? No? All right. Nobody's developing anything? It's cool. All right. So I've got a simple Ruby app, and I'll walk you through it. It's pretty easy to read. It should be pretty easy to understand. So within the Ruby ecosystem, I just want to review this code a little bit. We've got a gem file, and a gem file in the Ruby ecosystem is how you define third-party libraries, right? And their potential versions and the version of Ruby we want. So Puma happens to be a web server. Sinatra is a lightweight, RESTful web framework. So it lets you build. It's particularly good at building RESTful APIs, and it also keeps the code nice and lean, so we can get to the heart of the matter. And then we've got Sinatra contrib, which is neither here nor there. Just as a point, I want to mention that I'm using Ruby for this example because there are other frameworks like Spring Boot within the Java ecosystem that are even more automatic and well connected to Cloud Foundry in particular. And it's too magical. So I want you to understand what the platform is doing for you. So I'm kind of taking that magic away from frameworks that would otherwise be incredibly automated. So that would be like Rails or even Express in Node.js or Spring Boot, as I mentioned, in Java. So I want to kind of get to the heart of it, and I want you to see what the platform does. So we have a very simple application that we're building. We're going to bind to this magical IP address 0.0.0.0. And the reason we do that is because when you bind to this address within Linux, it says I will listen on any IP address or any network interface. Typically, things get bound to localhost, and that means that it won't listen out. But when you're running in a distributed cluster, when you're running a container that gets spun up on whatever virtual machine you happen to be assigned to, and then also within that virtual machine, you have network isolation. So your container has its own network interface, and that network interface has an IP address that you don't know, right? So as a developer, you can't hard code an IP address into your application. So this is sort of what it means to build like 12-factor apps. Who's heard of that concept? A couple of folks. So 12-factor apps are a set of software design and architecture principles where your applications will run better in the cloud, run better in distributed environments if you adhere to them. So we'll talk about a few of them here today. But there is a website called 12factor.net. If I had a whiteboard marker, I would write all over this wall. If that's possible, if anyone has one. Or a Sharpie.
Not a Sharpie, okay.
Oh, here we go. Is that what this is? This is an eraser, I believe.
That's for the digital whiteboard.
Oh, that's weird then. Okay. Yeah, cheers. Okay. Then we'll move on. So for ports, it's the same thing. You can't hard code the port that your application should be bound to. So in the old school world, you had port 80 or port 443, right? And you could pretty much guarantee, like, I will hard code this port into my application, and that's where my application runs. But that isn't the case in a distributed, clustered environment. You're running many containers on an individual virtual machine, and then you've got maybe dozens or even hundreds of those. So the platform itself, the elastic runtime, will provide you a port, and you can inspect it off of the environment. So this is another one of these 12-factor principles, which is that you should get your configuration information from the environment itself. And that's pretty critical.
And just make sure it's a whiteboard.
Well, so am I.
Can you wind up?
From my pocket. All right. Look, this show isn't 100% foolproof, so.
See how the white works. That's all right. All the walls are whiteboards.
So, 12factor.net. There are a bunch of essays about 12-factor applications. Definitely worth a read. Go check it out after this talk. So we're going to get our port information off of the environment. If we choose to, we could fall back to a hard-coded port. This might be good for development, right? But our port's going to be something like 65,423. And then in a different instance of your application, it's going to be some other number. You just don't know. So you'll just get it off of the environment. Our JSON API endpoint here, it's going to produce JSON, as we mentioned, when we go to this application. The key will be instance, and the value will be another environment variable called CF instance index. So the instance index within Cloud Foundry, this is something Cloud Foundry provides. Cloud Foundry provides this to allow you to investigate which instance number you're running. But as you horizontally scale an application, this starts at 0 and it goes up. So if you have 100 instances, this will be a number between 0 and 99, right? Typically, there are only a handful of scenarios where this actually matters in a production environment, but it is a good way to show that the platform does things like horizontal scalability, right? So super simple app. We're almost ready to deploy it. Another key principle is that there's this manifest.yaml file. Can we read that, or is that okay? So the manifest.yaml file is a way to tell Cloud Foundry some operational expectations for this application when it's running in the platform. And you can put a whole bunch of things in here. This one is very, very simple. I'm just going to define a name for the application, which you'll find out later is incredibly hard to say well and also type. So I'm going to need pair programmers. If you see me mess up, let me know. But it's going to be CWest CFENV. I'm going to hit a memory cap. So I'm going to say this application, each instance of this app can't have more than 20 megs of memory. So if it were to have a memory leak and it went over 20 megs, the platform would notice, shut down that instance, and spin a new one up in its place. This is kind of neat because if you code poorly and you keep memory leaks in your application, the platform will work very hard to keep your application alive. On the other hand, if you're not monitoring your application by checking the events that the platform emits, such as I keep killing your instances because they keep running out of memory, then you might leave that memory leak in and never realize it happened. So kind of a double-edged sword there. But I imagine that we would accept uptime over the alternatives, right? And then I'll just say that to run this app, because it's very simple, it'll be Ruby app.rb. So super simple. I want to deploy this app. So in a world without a minimum viable platform or without something like Cloud Foundry, which the DTO is building on top of, you probably have to go through a provisioning process to get hardware and network and DNS and I don't know, authentication whatevers and VPNs for days, right? Maybe months. But within this world, if you have this platform available, if it's already ready to go, if it's been sanctioned, if it's been vetted, if it's been made available to you, and you have access, then deploying an application is pretty simple. I'm just going to type cf push. I'm in my application directory. If we were going to production, I just want you all to pretend that what I'm doing here would actually be done by something like Jenkins. So everything I'm typing would be done by robots, right? And rather than just deploying from master, we would deploy from a semantically tagged version of our application, like version 1.0 or 1.0.0. But for the purposes of demonstration, we're going to go through it manually. So I'm going to type cf push, and I'll kind of explain what's going on here. So I mentioned that we need an immutable artifact. So Cloud Foundry takes the application in your current directory and uploads it to a staging area within the platform. And staging builds a container. So what it does is it looks at the application, and it says, it asks, what kind of application is this? And it runs through a few options that it already knows about. So it might be a Go app, or a PHP app, or Python, or Ruby, or Java, et cetera. It determines, though, that it's a Ruby app, and it knows that by looking at the application itself. In this case, a gem file indicates it's a Ruby app. A pom.xml, or a jar file is going to say that it's a Java app. Sometimes things don't work super great, and we'll find out if it's because I don't have internet access. I believe you. We're going to try it again. So yeah, the demo gods will be with me. So it looks at the application, determines it's a Ruby app, and then it starts to build out a runtime for that Ruby app. There we go. So I said I wanted Ruby version 2.2.3, and it knows that it's going to be a Ruby app, so it goes and gets version 2.2.3. And then it knows that I need to run bundle install in order to install my third-party dependencies in the Ruby ecosystem, so it runs that, and it installs all the libraries I need. And then it puts my application in that container. It bundles it up. We call it a droplet. So it says it created this droplet and uploaded it. That's up here. And that's the staging process. It puts it into a central repository, and now we have an immutable artifact that we can spin up and spin down and ship around, right? The platform did all of that for us. And then it went ahead and started up the app for us as well. So it gave me a URL. I can control this and define it if I wanted to, but I just took the one that it had available. And it also ran an instance, and it says it's running right now. And we're using about 17.5 of those 20 gigs of memory. There are some other potential limits, like disk and CPU utilization, but right now I didn't specify those, so it'll just go to defaults. But I have one of these instances running, and if everything goes right, I should be able to go to it in my web browser. OK. There we go. So we have instance 0, right? And if I reload, we can see it's instance 0 all the time. I mentioned log aggregation is one of these things that you definitely need. I want to do it this way. So in a different terminal window down here, and I'm going to keep it small because you don't actually have to read it, but I want to tail the logs, right? So if I make requests, I want to be able to see those requests coming in. So I've got this app running, and its name is CWest CFENV. So I will do CF logs CWest CFENV. And I will make this a little bit bigger. So it says connected and tailing the logs, right? Now, we don't have any requests yet, but if we do start making requests, we should see the logs come in. It's not perfectly real time, but it is pulling those logs in from our Elastic runtime and spitting them out. So if I reload, we can see more logs, right? So that's pretty cool. Although we only have one instance, so like, how do you know that this isn't a charade? We don't know if it's actually aggregating those logs across all the instances because there's only one. So let's scale our app up. Let's say that we're getting a lot of traction. People really like our app, and they want to use it. So we'll say that we want 3 instances. I'll just use the CF scale command, right? And there we go, 3 instances. And we'll take a look. We can see in the logs that we're spinning up 2 new instances. If I run cf app CWest CFENV here, then I can see some characteristics about my running application. I can see that I have 3 instances. That's pretty cool. And if I reload, we can see that the load balancer scales across our instances because we can see these numbers changing. And we can see that our logs are also being aggregated. And they're coming in from whichever instance we hit. So that's pretty cool. It's pretty neat that because I had Cloud Foundry available to me, pushing an app and getting all of these capabilities was just out of the box, right? That might take a little more time in other environments. I have been there. I have felt that pain. And that's why I do this at Pivotal now, because I want other people not to have that pain. Even if you don't use anything we make, like these are just good ideas, and you should be working toward this. So I mentioned earlier that if you don't connect to anything, and if you don't manage state in some capacity, then you've really just got a toy, right? And I do agree with that. I do believe that. And I think the next thing that I'd like to show you very quickly is a better version of this application. So let's This works better in industry, but what I want to do is I want to take this from a toy and make it enterprise grade. I'm sure that we talk about enterprise grade here. How many of us are building enterprise grade software? Yeah. So some people say they are. It's cool. We'll go to lunch later. I'm sure it'll be fine. So what I'm going to do is because I'm a professional, I'm not going to live code. I've got this stuff in a branch because we check in our code and we keep it in branches, right? So I'm going to check out my branch called Enterprise Features. And I want to take a look at this code now where we're going to build some enterprise-grade functionality, right? So let's take a look at the code very quickly. We'll call this like version 2 of our app, right? So the first thing that I'll note is that in the manifest, I've increased my memory allowance from 20 megs to 50 megs because 150% increase is probably enterprise grade enough, right? But if our application goes beyond that, it would still get shut down. But now we're going to say each instance can have 50 megs. Now we're going to look at this app. Well, let's look at the gem file first. So I'm going to use a gem called CF App Utils. This is a utility in the Ruby ecosystem that helps you get environmental information for an application and make it available in a nice object-oriented way. In particular, authentication credentials and other types of access information that you might provide to an application for things it wants to talk to. Those come in over environment variables to your application instances, and then you inspect those environment variables, and then you can set up things like a connection to Redis. And I'm using Redis as my data store because it's super enterprise grade, and you can trust it, and it will never lose any of your data, ever. So just write that down that if you want to use a high available data store, use Redis. I have to push this so far until I hear people laugh. So Redis is more of a caching layer, although it can demonstrate that we can manage state externally. It's about 50-50 for me that whenever I make a deadpan joke about Redis being reliable, that the entire room erupts in laughter or someone gets very angry. Or that doesn't happen at all. So one of the things that I don't want you to tweet is that Casey West said Redis is a reliable data store and I can build enterprise-grade applications on it. I'm serious though. So I'm going to use Redis as a good demonstration, right? But we'll use it as a backing data store. So now let's look at our app. How are we going to make it enterprise-grade? Well, obviously, we're going to build analytics. It doesn't matter what you're analyzing or analyticing. Just if you say analytics, then your application will be more enterprise grade. So if someone pulls you in to a meeting and asks you to build enterprise grade software, just say, I'll add analytics, no problem. And they don't know what it means either, so it doesn't even matter. But we're going to build analytics. So I've got this class called analytics. I'm going to connect to Redis, and what I want to do is get the connection information off of the environment. So we can see that we're going to build a new Redis client library instance, and we're going to get credentials from this method here. So we're going to get credentials off of the environment. This is a nice wrapper for doing that, and I'll show you what it looks like at a lower level in a second. But I'm going to find all of the services that match the tags Redis and Pivotal, and I'll get the first credential off the list. If there aren't any, this will throw an exception, in which case we'll just return the default, which will assume a local default environment. But if we do have credentials, we'll fetch the host, port, and password information off of the environment. Again, this is not hard-coded. This is an important aspect. I've got a backing service that my application is going to rely on, but I'm never going to hard-code the host name, the password, or the port into my application. So no one is ever going to pass that into me. I'm not going to put it in a properties file or a configuration.yaml file or some other place in my code where we're going to pretend it's a configuration file, but it's really a critical piece of your software. Like, that doesn't happen in this world. In this world, something else manages my credentials and my access to backing services, and then gives me the information I need when my application starts up. So the type of analytics that we're going to do is that we're going to track visits to this API endpoint. So every time we get a visit, we'll just increment a number. And then we'll change what we display on JSON to increment our visits by 1 every time we do it. And so hopefully this will demonstrate that we have a horizontally scaled application across a cluster of computing resources that's connected to a stateful backing service, and that connection is shared, is available. Shared is a touchy term. Is available to all the application instances, and the state is shared between them. All right. So I want to deploy this new version of this application. So what I'll do is I'll do cf push, and then we'll push a new version. similar to the same thing that happened before, and because we're building immutable artifacts, our droplet, which is our container image name, our droplet will be rebuilt. We'll build a whole new one, and it's another snapshot point in time for this application. The platform keeps the old one, and we could do blue-green deployments if we wanted to switch between them carefully so that you don't have any downtime. Who knows about blue-green deployments, that concept? A few folks? Sure? So this is just an idea of being able to roll to a new version of an application relatively seamlessly without any downtime. And that's supported within the system, but that's not really like the intro level class. All right, so we just deployed a new version, and it spun up 3 instances because that's how many we had before. And I want to make a point here that, again, immutable infrastructure means that we're not patching or updating a server or updating a service. All right, that's actually a horrible practice that leads to inconsistent state in virtual machines, inconsistent state for application environments. So what we're actually doing is completely destroying and obliterating the old instances. They do not exist anymore. They do not run. And spinning up completely new ones with this new version of our software, right? So it's always destroy and run, destroy and run. So let's go ahead and go to this application and see how it works. It doesn't work. That's cool. So we had an internal server error, and we had an exception, which came in over our logs. Can anyone have a guess as to why we got an internal server error? No guesses. That's cool. Just waiting for me to scroll up to the top of this long thing here. All right. So we got a Redis connection error. So it turns out that I didn't make a Redis available. Like, I don't have Redis. So it couldn't connect to anything. So what I want to do is I need to have a Redis. So my application requires this database or this data store, this backing service. So I want to be able to provision it and make it available to my application, right? This is one of the harder things that you have to do when you're trying to deploy new things or change your architecture. In typical environments where you have to procure things in a relatively long and paperwork way. But it's relatively easy within the platform. There's a concept of a marketplace. And I appreciate you all sticking around. I know that we just hit 11 o'clock, but if you bear with me, this is totally going to be awesome. And then we should go to lunch or something. All right. So there's a marketplace of available services that I can provision that are available to me as a developer, right, or as a user of the platform. I'm using a local copy that's running on my laptop, and it only has a handful of services. It has MySQL, RabbitMQ, and Redis. It's pretty handy for me right now that it has Redis. The other ones, we could play with it at a later time. But I want a Redis instance, and I don't have any available. These are things that can be made available, can exist, but it is not a description of things that exist. We can use the cf services command to show any services that are currently running. And again, it's within our org and our space, right? So these are services that are only available to applications in this particular environment. So what I want to do is create a service. Oh, yeah. Yeah, that's all we need.
Okay to hang around for another 10 minutes?
10 minutes, it's worth it. OK, so I'm going to create a service for Redis. And I'm going to pick a plan. In this case, it's a shared VM. And by the way, in your Cloud Foundry instance, you may have dozens of services. And they could be anything from MySQL and Redis to the ability to connect to existing services elsewhere, like an Oracle database that's somewhere, or an API that has been written on top of a mainframe, or whatever it is that you've got, right? Those can be services that are available to you if they're meaningful in your context. But in this case, I'm going to create a service for Redis. And we'll just give it a name, cf env Redis. And now we have a service. So that just created a Redis instance. And we can see that it's running using cf services. A critical piece here, though, is to see that there are no bound applications. So we separate the idea of allowing applications to connect to services from the provisioning of those services in the first place. Because sometimes you're provisioning a service from scratch. Sometimes you want to connect to an existing service. So create doesn't always mean the same thing, right? But what we want to do is make our application be able to talk to this Redis instance. Right now, it's completely alone. And nobody likes that. So we're going to bind the service to this application. And that happened. So what this does is it creates the network links between my application and the service. It also auto-generates the credentials. No human had to do that. What's neat about this, by the way, just as an aside, is that if you ever wanted to cycle credentials, which is kind of an important thing that unfortunately gets missed a lot, but if you wanted to cycle your credentials between services and applications, all you have to do is unbind the app and rebind it. New credentials are generated, you restart the app, and it's available. Super easy. So now that we've got this bound app, we can go ahead and check that out. And that's cool. It tells us that we should restage our app. Now, this basically means that we need to restart our application. And the reason we need to restart it is because to provide environment information to an application instance, the only time that you can actually make a change or make an adjustment to that is when the application instance spins up. So you really only get to do it when the application starts. And we currently have running instances, and they don't know about the environmental properties that give us access to Redis yet. So we want to spin up new instances in its place. But before I do that, I want to show you what that environment looks like. There's an application or a command that we can run called cfenv, which will get the environmental information that is provided to your application instances and let you see it if you have access to do this. And it does decrypt that application information. These credentials are otherwise fully encrypted and encrypted at rest, and then they're only unencrypted and provided to your applications when the instance spins up, right? But we can also do this which is helpful for debugging. So we can see that there's an environment variable that has a JSON payload, and it's called vcap services, which is a historical name. It's not interesting. But you can see that it has credentials, host, password, and port. The password is, again, fully auto-generated. No human had to do this. You didn't have to manage it externally. You didn't have to pass it around. You didn't have to hope that someone typed it in correctly. It's just there. We can also see that this particular service, predis, happens to have these tags that I was looking for, so that's pretty helpful. There's some other information that you can get about your application as well, like the limits that are applied to it, GUIDs for where it exists and what version it is. And that's all cool. So now I'm going to restart my app. And my throat's going to get dry. So we restarted our app. And here we have instance 2 and visit number 1. And if we reload, we can see that we're still load balancing across our instances and our visits are going up. We just used incredibly modern software to build like your 1997 level CGI script to track visitors to your GeoCities or AngelFire page. But that's cool. I think it's still pretty neat. Maybe we scale this up a little bit more. So it'll do converge state. It knows that we already have 3 instances running, so it's not going to shut those down. It also knows that we're not trying to upgrade, but it'll spin up new ones in it instead, and we'll start to see their instance numbers kick in here. We see instance 3, which is actually instance 4. And if we do cf app, we should be able to see that we have these 5 instances running. Sometimes it's hard to overload it to get to higher instance numbers because I'm not really doing much damage here. But within, about a half an hour here, we were able to deploy an application twice, auto-provision backing services, get routing, DNS, load balancing, log aggregation, responsible developer enablement when it comes to things like credentials and access. And I think that's pretty cool. So that's kind of what it means to have an operationally mature environment to work with, is that you get to do that, right? And what I showed you, like, if you had a sandbox environment for developers, imagine the amount of creativity you can get out of it, right? But I did go over time a little bit, so I want to get to questions, and I see someone who wants to ask a question in the back.